Okay, here are your notes on continuing with how to deal with division when you have exponents, and this one, as you can see, is titled Power of a Quotient. So you've seen what to do when you have division of exponents. So as a quick review, when you divide exponents, you subtract them. When you multiply exponents, you add the exponents. And now, and then you also learned that when you have a power of a power, so an exponent to an exponent, you multiply those exponents. And so similar thing's going to happen here. So we'll just see what's going on. But you can see on the rule over here, so the power of a quotient, if you have a quotient, meaning a fraction, a division problem, raised to a power, then that power gets distributed to everything on the numerator, but it also gets distributed to everything on the denominator. And that makes sense because if you repeat a fraction, this would just be a over b times a over b times a over b, however many times the exponent told you. And when you multiply fractions, you multiply across the top, so you'd have n number of a's on the top and you'd have n number of b's on the bottom. So that's why the exponent gets handed to the top and the bottom. So we'll go through these examples. Remember, take careful notes, make sure you understand, pause if I'm going too fast so you can catch up, rewind if you miss something. There's only 6 problems, so take your time. All right, number 1. Here we have 4/7 to the second power. So the rule says we apply this 4 to the 2, or the 2 to the 4 and to the 7. So we would end up with 4 to the second power over 7 to the second power. Well, you can do 4 to the second power, that's 4 times 4 is 16. And you can do 7 to the second power, that's 7 times 7, which is 49. Now you always want to reduce a fraction, but you actually know that there are no factors in common that you can cancel out between 16 and 49, because when you, whoa, I didn't know you could do that. I don't want to do that. If you look up here, all that's on the top is a 4 and a 4, and all that's on the bottom is a 7 and a 7, and there's nothing that you could have canceled there, so there's nothing you can cancel in this answer. All right, number 2. Okay, so now we have our power of a quotient, but also our power of a product, and we're also going to have a power of a power. So these rules start to combine, and that's why we're doing a lot of practice. So this 4 is going to get handed to everything on the top. So we have a 3 and we have a d squared, and then it's going to go down to the e and to the f. So here's what that looks like. 3 to the 4th, d squared to the 4th, over e to the 4th, f to the 4th. Okay, so that's just the first step of using our power of a quotient. And now we have to do some cleanup. So 3 to the 4th, you can punch that into your calculator, but it's 3 times 3 times 3 times 3, which you'll find out is 81. Now we have d to the 2nd to the 4th. So this is the rule. If you have this 4 to that 2, you really have 4 d to the 2nds. So that's d to the 2 times 4. So this becomes d to the 8th. And then at the bottom, you have no more cleaning up to do, so you get e to the 4th, f to the 4th. All right, you can't see the number 3, but there's number 3. And don't get overwhelmed by these, just take them step by step. So on the top, the 2 is going to get handed to the 2 and to the x cubed. On the bottom, the 2 is going to get handed to the thing in parentheses, and then we're going to have another step that we're going to have to do here. So hopefully I have room. I'm going to write it to the left so that I can fit more in here. So we have 2 to the 2nd, x to the third to the second is x to the sixth. And on the bottom, we have xy to the third to the second is xy to the sixth. Because that 2 and that 3 multiply. Okay, so then 2 to the second is 4, x to the sixth over, now this 6 gets handed to the x, gets handed to the y. X to the sixth, y to the sixth. Now here we have some reducing we can do because we have an x to the sixth on the top and an x to the sixth on the bottom. Now you can just see that those will cancel each other out. You could also use the quotient rule, which says that you're going to subtract exponents, 6 minus 6, and 6 minus 6 is 0. X to the 0 power is 1. So in either case, these cancel out to leave a 1. And so all that's left on the top is a 4, and all that's left on the bottom is a y to the 6th. Number 4. Okay, so now we're going to introduce negative exponents, and we'll deal with the negative exponent last, but first we want to use our power of a quotient rule. So the negative 3 exponent gets handed to the 3 on the top and to the 4 on the bottom. So you have 3 to the negative 3 over 4 to the negative 3. Now remember, we don't like to leave things with negative exponents, so the 4 to the negative 3 is going to flip to the top and become a positive. This 3 to the negative 3 is going to flip to the bottom and become positive. So we end up with 4 to the third on the top and 3 to the third on the bottom. Okay, and then 4 to the third is 4 times 4, which is 16, times another 4, which is 64. And 3 to the third is 27. And you can just leave it like that. Number 5. The exponent gets handed to the 2, to the x squared, and to the y cubed. So we have 2 to the negative 2. X to the 2 times negative 2 is negative 4. Y to the 3 times negative 2 is negative 6. Now, everything's negative, so everything's going to switch to the opposite part of the fraction. So the y to the 6 goes to the top and becomes positive. 2 to the negative 2 goes to the bottom and becomes positive. And the x to the 4 goes to the bottom and becomes positive. I'm just cleaning that up a little bit. Y to the 6th over 4, because 2 to the second is 4. X to the 4th power. Okay, this next one, we actually have a multiplication. This is number 6, and it's not written, but I'm going to write it there. There could be a little multiplication symbol between those two. So to deal with this, let's clean up each of the parentheses first, and then we can multiply. So working on the left one, that's 2 to the negative second over 3 to the negative second, because we handed the exponent to the top and bottom, times 6 to the negative third m to the negative third over 2 to the negative third n to the negative third. So I've just used my power of a quotient rule and handed that negative 3 exponent to everything on the numerator and denominator. Now on this fraction on the left, these need to switch places to make the exponents positive, so we have 3 to the second over 2 to the second. The same thing's true in this other fraction, basically flipping the whole thing upside down. 2 to the third, n to the third, 6 to the third, m to the third. Now there's no reducing we can do with the variables, but we can with the whole numbers. So there's different ways you could go about this. I like to reduce before I multiply everything out. So what we have, let's deal with the 2's. So you have a 2 to the third on the top and a 2 to the second on the bottom. Using your exponent rule, that's 2 to the 3 minus 1. So I'm going to continue up here. Give yourself a little bit more room. So 3 squared times 2 to the 3 minus 2, which is just 1, times n cubed over, that 2 squared is gone now because we dealt with the 2's, so 6 cubed m to the third. Notice how I'm just kind of doing one step at a time. That was a mark that doesn't belong. Okay, now we have a 3 squared on the top and a 6 cubed on the bottom. So 3 squared is 9. So we know that there's some 3's that we can cancel out here. So, but they don't have the same exact base. So maybe it's easier just to multiply this one out. So we get 9 times 2, which is just 18. So let me write it as 18. 18n cubed over 6 times 6 is 36 times another 6. If you punch that in your calculator, you should get, I'll do that off to the side, I think it's going to be 216. 6, 3, 18, 21. So we have 216 m cubed. And then I know that 6 goes into both 18 and 216. It goes into 18 3 times. So I'm dividing by 6 here, and then I just did that multiplication problem, so this goes back to 36. And it turns out that 3 goes into both of these, so I can go 1 and 12. So all of this ends up being n to the third on the top and 12 m to the third on the bottom. Okay, so once again, if I went too fast on anything, pause, rewind, ask me any questions through Google Classroom.